Good morning to all. Welcome to the Diamond Group of Institutions NEET and K-CET online classes. Today's topic is biomolecules. In that some questions. Question 1. Read the following statements and find out the incorrect statement. How to find out the incorrect statement in the given options? Option A. Secondary metabolites are found in plant, fungal and microbial cells, and these are derivatives of primary metabolites. So here the question from the metabolites, those are two types, primary and secondary metabolites. So when we see into the secondary metabolites and the primary metabolites, these are the biomolecules. So in the living cells or the living organisms, some of the molecules such as sugars and DNA, RNA and proteins, amino acids we call as biomolecules. These biomolecules are there involved in a metabolism process. So that's why we call as metabolites as biomolecules. That metabolites are classed into two types, means based upon the formation. So these are the two types of the metabolites, are primary metabolites and secondary metabolites. The primary metabolites are which are the metabolites are there involved into the primary processes such as photosynthesis, respiration and growth and development. Such type of the metabolites all are we call as primary metabolites. And coming to the secondary metabolites. Secondary metabolites are the biomolecules, those are the derivatives of the primary metabolites, and these are the secondary metabolites. These secondary metabolites they are not involved directly in a growth and development. So those are we call as secondary metabolites, and the secondary metabolites in a plants are having several types. So option A, secondary metabolites are found in the plant, fungal and microbial cells, and these are the derivatives of the primary metabolites. Yes, based upon the concepts of the metabolites, option A is the correct statement. And option B, many secondary metabolites are rubbers, drugs, spices, scent and pigments are useful products. Yes, so many secondary metabolites are we are seeing in a plant. Those all are the rubber, drugs, spices, scents and the pigments are their useful products. And option B, what are the statement they given? These are the secondary metabolites. We are seeing into the secondary metabolites they are having useful into the human beings. And option C, some secondary metabolites are having economic importance. Yes, out of these many secondary metabolites, some of the secondary metabolites are having as a economic importance. So those are the metabolites are economic importance are rubbers, spices and scents. So we can collecting of these rubbers, spices, drugs and scents, and they can sell into the market to get into the economy. So that's why some of them are having as economic importance. And option C also correct statement only. And option D, secondary metabolites are the parts of basic molecular structures of primary metabolites. So now here secondary metabolites are there. So these are the secondary metabolites are the not a basic molecular structures. So here the primary metabolites are the basic molecular structures, not as a secondary metabolites. They given as a secondary metabolites are the part of basic molecular structures of the primary metabolites. So in that statement it's a D only. Right statements are A, B, C. So A, B, C are the right statement. D is a incorrect statement. Question was asked as incorrect statement on this one also. And next question. Latin key hypothesis of made of enzyme action. So we are studying about the enzyme actions. In these are the enzyme actions, latent key hypothesis and induced fit hypothesis. These are two types of the enzyme actions that we are going to study. So in that, latent key hypothesis was given by, latent key hypothesis was proposed by option A, Hume, Buckner, Porcelain and Emil Fischer. See now, Hume, one of the scientists, he was given the name of enzyme. Edward Buckner, he was identified the first enzyme, gymase. And Porcelain is a scientist, he was proposed the induced fit hypothesis. So remain as a Emil Fischer, he was proposed the lock and key hypothesis. So answer is Emil Fischer. And next, third one, which of the following option represents nitrogen bases are having six-membered single ring. So they given as a nitrogen bases. So out of the given nitrogen bases, which are the nitrogen bases are having six-membered single ring? We have to identify. See now, nitrogen bases at the time of molecular biology we have studied. So in the biomolecules also nucleic acids are we have to discuss under the nucleic acids. So different types of the nucleic acids such as the DNA and RNA structure and its types of the nucleic acids are we have to discuss. So the nucleic acids are made up of by the nucleotides, polymer of nucleotides. So that nucleotides are made up of by the nitrogen bases, sugars and phosphate molecules. So now nitrogen bases are four. Those are adenine, guanine, cytosine and thymine. So that nitrogen bases are classified into these are the four categorized into two. Those are purines and pyrimidines. Purines are the double membrane ring structures. Pyrimidines are the single membrane ring structure. Single ring structures. So now you see. So these are the purines of adenine and guanine. Adenine and guanine. Two rings are we are seeing into the adenine and guanine. Pyrimidines are cytosine, thymine and uracil. Instead of the thymine in RNA, uracil is there. So question it was asked nitrogen bases having six-membered single ring. So it should be contained as a six members and it means six carbons and it should be contained as a single ring. So these are the adenine and guanine. Two rings are there present. So that's why we call as heterocyclic rings. And cytosine, thymine and uracil, these three only we call as a pyrimidines and these three only they are having single membered six rings. So now option A, adenine, guanine, uracil. Adenine, guanine, these are the purine and uracil is a pyrimidine. Cytosine, pyrimidine. Thymine, pyrimidine, uracil, pyrimidine. Guanine, purine, cytosine, pyrimidine, thymine, pyrimidine. Adenine, purine, guanine, purine, and thymine, pyrimidine. So out of the given options, pyrimidines are having as a six-membered single rings. So in these are the pyrimidines. We have identified as the only pyrimidines as a cytosine, thymine, and uracil. So answer it is B only, not as a reminder. This next question. Which are the following groups of polysaccharides? Here we have to identify the correct groups for the polysaccharides. So you know poly means many, saccharides are the sugars. So out of the given options, which are they having many number of sugar? See now option A, sucrose, glucose and fructose. Sucrose is a disaccharide, glucose is a monosaccharide, fructose also the monosaccharide. And maltose, it's a disaccharide, lactose disaccharide, fructose is a monosaccharide. Now you see option C, glycogen. Many number of the glucose molecules are connected together 1,6 linkage. So glycogen is a polysaccharide, sucrose is a disaccharide, maltose is a disaccharide, and glycogen polysaccharide, cellulose polysaccharide, starch also polysaccharide. So out of the given options here, option D, glycogen, cellulose and starch. Here monosaccharides and disaccharides and polysaccharides differences are. So if the sugars will be done to hydrolysis, they can give further sugar molecules, that is called as a, they can give into the main number of the sugar molecules, those are called as the polysaccharides. If the sugars are taken undergoing as a hydrolysis, they can give into the two sugars only, such type of sugars are we call as a disaccharides. If the sugars are there hydrolyzed, they will not give into the further sugars, such type of the sugars are we call as a monosaccharide. So these are the glycogen, cellulose and starch are polysaccharides. If you done into the hydrolysis process, they will give into the many number of monosaccharides. So answer it is B. And if prawn is immersed in boiling water and then cooled, then the solution becomes sweet. If the maize seed is immersed in means kept in a boiled water. So then later that seeds will be going to cool. We know that maize seeds will be going to keep into the boiling water. The seeds contained as a starch will be going to hydrolyze, and these are the starch will be going to converting as a, that starch will be going to become as a sweet when we are going to keep in a boiled water and later it was cooled. So because they can, option A, monosaccharides are converted into the disaccharides. If you are doing as a boiling means we are also called as a one type of the hydrolysis process only. So option A they given as a monosaccharides are they converted into the disaccharides. At the time of the boiling, starch is a polysaccharide. So such type of the carbohydrates are they present in a maize seeds. So these are the saccharides or disaccharides will be going to present, otherwise sugars will be going to present, or we are also called as a carbohydrates are their presence. If you are going to boil, so that boiling, at the time of boiling hydrolysis is going to take place, and those are the disaccharides are their disaccharides are their presence means they can convert into the monosaccharides. Polysaccharides are their presence means the polysaccharides also they can convert into the monosaccharides and disaccharides because of the hydrolysis process. So option A they given as monosaccharides are converted into the disaccharides. If you are going to boil, so the complex molecules are converted into the simple molecules. Monosaccharide only simple molecule. Disaccharides are the complex molecules. So option A will not take place. Means monosaccharides are not converted into the disaccharides. And option B, enzymes are inactivated in boiling of water. Enzymes are inactivated in boiling of water. Here the conversion of the maize seeds into the sweet. So one form of the sugars are converted into other form. At the time of conversion, enzymes will involve, but these are the enzymes are that involved. The involvement of the enzymes are not a criteria for the conversion of the sweet that is formed into the sweet form. And here option B, they given as enzymes are inactivated in boiling of waters. So here enzymes will be going to work into the particular temperature up to the 35 degrees temperature to 40 maximum. So until the 40 degrees temperature, these will be going to work. And disaccharides are converted into the monosaccharides. Here, normal maize seed is kept in a boiled water. That maize seed later kept into the cold water, it will be going to become as a sweet because at the time of doing as a boiling, the complex molecules are converted into the simple molecules and they will form into a simple molecules are we call as a monosaccharides and complex molecules are we considering as a disaccharides. There, disaccharides are they converted into the monosaccharides. That monosaccharides are the simple sugars. So that's the reason these maize seeds, when you kept in a cool water after the boiling, it will be going to become as a sweet. That's the reason disaccharides are they are converted into the monosaccharides. So answer is a C. And option D they given as none of this. Out of the given statements, C is the correct statement. Means at the time of boiling, complex molecules are converted into the simple molecules. And next, identify the given amino acids and select the correct option. They given as a 3 amino acids. Out of the 3 amino acids, based upon the structure, they have to identify. So amino acids are the classified into several types. 20 types of the amino acids are we are seeing into the living organisms. So out of the 20 types of the amino acids, acidic amino acids and basic amino acids we are seeing. Acidic amino acids means which of the amino acids are we considering as acidic? They contain as a carboxyl groups of more. So this is the carboxyl groups of more. Here the one carboxyl group and here the other carboxyl group. So this is the we are called as a acidic amino acid. And basic amino acids so amino acids are they contain as more number of amine groups. Such type of the amino acids are we call as basic amino acids. And some of the amino acids are they contain as a sulfur. So sulfur contain of the amino acids are 2 only here. Out of the given 3 amino acids, one of the amino acids contain as a sulfur. Sulfur contain of the amino acids are 2 only, methionine and cysteine. So option A is a cysteine and option C is a acidic amino acid. So based upon options as you can see it is option A lysine, alanine and glutamine. So lysine it's not a sulfur content of the amino acid. And option B cysteine. Cysteine is a sulfur content of the amino acid means option A is a cysteine is a sulfur content of amino acid and it is a B glycine aspartic acid. Acidic amino acids are written, they having more carboxyl group. So acidic amino acid as a C. So maybe answer is B. Just check it is remaining. Methionine. So again, methionine is a that is sulfur content of the amino acid. Option A is correct. We can consider as a B. They given as serine and C valine. Valine is not an acidic amino acid. And next option A proline, valine and phenylalanine. So as sulfur content of the amino acids are methionine and cysteine. If you are taking as a cysteine as a sulfur content of amino acid A, that option C is having aspartic acid. So aspartic acid is a acidic amino acid. So if you are taking as a methionine as a sulfur content of the amino acid A, they are given as a valine. Valine is not a acidic amino acid. So that's why answer it is a B only. Cysteine A, B represent as a glycine and C represent as a aspartic acid. And next question, iodine test used to detect. Iodine test is used to detect the option A, typhoid, fats, carbohydrates and malaria. So iodine we are going to use to detecting of the different types of the molecules. So out of the different types of molecules, they given as a typhoid. Typhoid, for the typhoid confirmation test, it is a Widal test. Fats, carbohydrates. Here the fats. So fats will be going to it will be going to fats confirmation test and carbohydrate confirmation test and malaria confirmation test. So out of the given options, carbohydrates confirmation test it is. We are going to use as an iodine reagent. If you are going to add the iodine into a carbohydrates, wherever the carbohydrates are there present, so in this iodine color will be going to change and then form into a blue. If the blue color change it takes place, blue color formation is occur, so the components are having carbohydrates. So iodine is a confirmation test for the carbohydrates. So answer is a C. Next question, which are the following secondary metabolites used to drugs? So here they are discussed as a metabolites as a biomolecules. So the biomolecules are the metabolites are classified into two types, primary metabolites and secondary metabolites. So in the secondary metabolites, out of the secondary metabolites, some of the secondary metabolites are used as a drugs. So in the given options, which are the secondary metabolites are they can use as a drugs, we have to identify. See now, option A, arginine and resin. Arginine and resin, these are the plant secondary metabolites. Those are called as a toxins. And wind blasting and curcumin. Wind blasting and curcumins are the secondary metabolites used as a drugs. Anthocyanin pigments. So anthocyanin pigments are we can use as a pigmentation or pigments present in a flowers or plants. And option D, gums and cellulose. So these are the gums and cellulose are the polymeric substances. Polymeric substances. So the out of the given four options, the four options are belongs to the secondary metabolites only. But out of the some of the secondary metabolites only they can use as a drugs for the different types of the diseases. So out of the given options, wind blasting and curcumin are the drugs of the secondary metabolites. And next, ninth question, biomacromolecules are collected in. So now, biomolecules are classified into two types based upon the size. Those are biomicromolecules and biomacromolecules. So based upon the sizes, biomicromolecules means which are the biomolecules that are having less than 800 Daltons. So those are the biomolecules we call as a biomicromolecules, amino acid, sugars, and biomacromolecules, which are the molecules that are having more than 800 Daltons, we call as a macromolecules. So example as nucleic acids, DNA and RNA, polysaccharides. So now under the biomolecule, the biomicromolecules and biomacromolecules, we are going to collect it is here the biomicromolecules are when we turn into the filtration for these biomolecules. So in this, small sized components, means which of the molecules will be going to present as small in size, that is less than 800 Daltons. These all of the molecules we are going to collect it into the test tube. Means acid soluble fraction we call as, this is called as acid soluble fraction. So here we get the micromolecules or biomicromolecules, and some of the biomolecules are there present in a funnel only. So such type of the molecules are we call as a macromolecules. So they are having more than 800 Daltons. So now the question was asked as a biomacro, means large size molecules. Large size molecules are there, they are collected and in a filter or funnel only because they are having more than 800 Daltons. So here this is the acid soluble fraction and this is the acid insoluble fraction. So now under these biomicromolecules, which are the molecules are having less than 800 Daltons? So those all are called as biomicromolecules. But here exemption condition it is lipid. Lipids are the biomicromolecules only, but we are not collected from the acid soluble fraction. We collect it the acid insoluble fraction. So lipids are the biomicromolecules, will not collect the acid insoluble fraction. So sorry, lipids are the biomicromolecules, will collect it from the acid insoluble fraction, not from the acid soluble fraction. So means lipids are will collect here, but these lipids are having less than 800 Daltons only. Basically they belongs into the biomicromolecules, but will collect it to the acid insoluble fraction. So biomacromolecules are basically going to present acid insoluble fraction, that is in a funnel. So acid insoluble fraction, they are given as acid insoluble fraction, acid soluble fraction, ash. Ash means by the boiling of these biomolecules are living organisms will get into the black color structure, that's only we call as ash. So and remain as a both molecule. So out of this acid insoluble fraction. And the next question, single stranded DNA, ssDNA represents as single stranded DNA. Single stranded DNA found in options are given as 5174 bacteriophase, lambda bacteriophase, T2 bacteriophages and M3 bacteriophase. These are the bacteriophases. So this out of the bacteriophases all 5174 bacteriophase is a single stranded DNA presence, and remain lambda bacteriophase and T2 bacteriophase and the M13 bacteriophases. These are the bacteriophages are contained as a double stranded DNA, but this one only is contained as a single stranded DNA. It's contained as a single stranded DNA. Its size is 5386 nucleotides only. That is answer is C. And next question, which are the following sequences correct on the basis of increasing the molecular weight? So options are given as a, means we have identified as a which option is correct based upon the ascending order. So DNA is a that is macromolecules. It's a polynucleotide structure. It's contained as a large in size. So option A, DNA, ATP, NADP, AMP. DNA, deoxyribonucleic acid, adenosine triphosphate, nicotinamide adenine diphosphate, and adenosine monophosphate. So here question was asked as an increasing order. Means increasing order means small to large, but option A is given as a decreasing order. So option A is incorrect. And option B, adenosine monophosphate, adenosine triphosphate, nicotinamide adenine diphosphate, and DNA. So that adenosine monophosphate to DNA, it is called as an increasing order. And option C, adenosine triphosphate. Actually, increasing order means adenosine monophosphate should be present as a first. See now, DNA is a polynucleotide structure. Adenosine monophosphate is a, compared to the adenosine triphosphate, its molecular weight is less because one phosphate only presents. Adenosine triphosphate and adenosine triphosphate. Here this nucleotide is contained as a 3 phosphate, so that's why that molecular weight of the triphosphates are ATP is more than into the AMP. So adenosine monophosphate to the adenosine triphosphate, NADP, DNA. It is the increasing order. So answer is B. Next question. Number of nitrogen bases in a single stranded DNA of bDNA with 100 turns. So here the question is, we have to identify as number of nitrogen bases in a single stranded DNA. So the DNA is a single stranded and that belongs to the bDNA which contains as a 100 turns. So bDNA is a double stranded DNA. Out of the double stranded DNA, one strand we have to choose, and in the one strand how many nitrogen bases are there present. So bDNA is a right-handed DNA. So we know different types of DNAs are we can see A, B, C, E and Z. So out of the stable DNA, it's bDNA only, it's called as balanced DNA. So when we see into the bDNA, it's a right-handed helix. It's contained as a right-handed helix. So these are the helix are having turns. You know that. So DNA will be going to present as a many helix. So each turn they are also called as a coil, or they are also called as a helix. It is equals to 3.4 nanometers or 34 angstrom units, or it is also equals to 20 base pairs. So the base pairs means we consider as a one strand, and means we consider as a two strands of the DNA. So but the question was asking as a the bDNA with having 100 turns of the single stranded. We have to identify as a number of nitrogen bases, not into the nitrogen base pairs. So nitrogen bases with 100 turns. So each turn it's having, each turn of the bDNA is 3.4 nanometers, otherwise 34 angstrom units. It is contained as a 20 base pairs. 20 base pairs. So now you see here, 20 bases, it is a 10 base pairs. So now we have to identify into the how many number of nitrogen base pairs are present in a 100 turns. So 100 turns, each turn contains as a 10 base pairs, that is equals to 20 into bases. So now 100 into 10 will be taken to the 1000. So for the 100 turns, 1000 nitrogen base pairs are there present. Out of the 1000 nitrogen bases, you can consider as a 1000 nitrogen bases. So from here to here 100 turns means here to here 1000 base pairs are there present. 1000 base pairs are there present means 1000 into 2000 bases. But they are asking into the out of the 2000 one strand of the DNA. So here they are taken as a 100 turns. Each one of the turn it's contained as a 10 base pairs, means it is equals to 20 bases. So but the question was asking as a single strand only. So the 100 turns contain as a 1000 base pairs. Out of the 1000 base pairs, we have to identify as a how many number of bases are present in single strand. 1000 base pairs means each one of the strand contain as a 1000 and a 1000. So total number of bases equals to 2000. But the question was asked as a single strand nitrogen base, a single strand of the DNA only, means each strand is combined as a 1000. So answer is 1000. So bDNA with 100 turns, it is contained as a 1000 nitrogen bases. And question number 13, which of the following enzyme is used to join bits of DNA? So we have studied as different types of the enzymes. Six classes of the enzymes are studied. Out of the different types of enzymes, which enzyme is used into the join the bits of DNA? So out of the different types of enzymes, one of the enzyme will be going to use into the joining of the small strands of the DNA. Options are lipases, nucleases, DNA polymerases and endonucleases. So lipases are also called as a molecular glue. So these are the lipases enzymes are used into the attachment of two small DNA fragments. And option B, nucleases, they cleave the DNA molecules. And DNA polymerases are they can synthesize the complementary nitrogen bases. And endonucleases, they can cleave the DNA inside. So those are the different types of enzymes. Out of the different types of enzymes, lipases enzymes will be going to use into the binding or joining of the two DNA strands. So answer is lipase.